Now let us discuss the concept of couple in this lecture. The definition of couple: two vectors of equal magnitude and opposite direction parallel to each other form a couple. So F vector equal in magnitude and opposite in direction and parallel to each other but not collinear will form a couple. Now if you sum this force, it will go to 0, but the moment will not go to 0. So if we write the force vector for this about O, so RA the position vector and this is the force vector, RB is this position vector to B where the force is acting, and if you just take the moment and add, we get RA vector minus RB vector cross F vector. So simplifying this RA minus RB as R vector, and we get this couple as moment. So this is called moment of a couple, that equals to position vector between the two forces, okay, and cross F vector. Now the magnitude can be written as R F sine theta equal to force into the distance between the two forces. The significance here is this position vector R is independent of the coordinate axis. So the couple is a moment and it is a free vector. So couple is a free vector which gives a tendency of the body to rotate. The effect of couple is rotating the body. So the direction of moment is perpendicular to the plane on which two forces are lying. Now, moment of a couple, two couples will have equal moments when both these conditions are satisfied. That is, this force and the perpendicular distance should be equal to this force and the perpendicular distance, and also the planes are parallel to each other. So if the two couples lie in parallel planes or in the same plane and have the same sense. Addition of couple can also be added. You have two forces F1 F2, and opposite to F1 there is another force, and opposite to F2 there is another force, and this is the resultant and this is the resultant. Now the position vector R for the resultant is this. So R vector cross, this is the position vector and this is the resultant vector of the two forces, equal to position vector cross F1 vector plus F2 vector. So R cross F vector, F1 vector plus R cross F2 vector. So this is moment 1 and this is moment 2 vectors. We can simply add for the moment equal to M1 vector plus M2 vector. Couples can be represented by vectors. So you know, when two forces are in a plane and the direction of the couple, it is an anti-clockwise couple, and you see that it is equal to, this is the direction. So the moment of this couple is nothing but force into the perpendicular distance between the forces, which is forming couple. Since this couple is a free vector, you can move this vector to the axis also, the coordinate center. Now it is inclined to all the three axes, so it could be written as the coordinates mx, my, and mz, all are anti-clockwise. So this is equal to this. This is equal to this. This is equal to this. All these are equal. In any form, you'll be able to write. So the couple can be represented as vectors, rectangular vectors as well. So if you see this, okay, you have a 30 lb force acting this direction, and opposite to that, these are parallel forces, opposite, equal in magnitude, and these two will form a couple about x-axis. So about x-axis, 30 into the distance between the two forces, that is 9 plus 9, 18. Now you have other two forces. This is also equal and opposite, but it is, if you find the perpendicular distance, or the distance between the two forces, it will be inclined. So what I do, I'm just introducing a force here, 20. I'm also introducing a force 20 here. Okay, that means parallel to this, opposite to this, 20. So this 20 and this 20 will nullify each other. That means it is not producing any effect. But this 20 lb and this 20 lb will form an anti-clockwise couple about y-axis. So y-axis is 20 lb into the distance between the two forces, that is 12, and the sign anti-clockwise is positive, so 240 lb inch. The first one is clockwise, so it is negative. And the third one, this force now formed a couple, another force is here. Okay, that force and this force will form a couple because these are parallel and opposite to each other. The perpendicular distance is 9 inch, so this will form an anti-clockwise couple. So 20 into 9 inch will give you 180 lb. So this is how we have to solve this problem. It's pretty simple. And now some more things we have to understand. Resolution of a force into a force at O and a couple. Can this force be transferred to this point? Generally, the point of application cannot be transferred, but if the net effect is unchanged, you can do that. I'm introducing another force, same magnitude in this direction and opposite, and now you see it is having no effect. The net effect is unchanged. Okay, now this force and this force will form a couple, and the same force is now transferred to this point that is given here, and this force and this force forming couple, that will be perpendicular to the plane on which these two forces are lying, and that is given as the moment. So the moment is equal to force into the distance between the two forces. So now it can be reduced like this. So this concept is very well or being used in many places where this force can be transferred to a particular another point, where you introduce a moment so that the effect of this force on this body is translating it as well as rotating it about O. So both the effect will be existing here. The moment will be causing rotation, and this force will try to translate the body. Both effects are not altered. Now let us solve this problem.
Let us discuss this problem. A shaft with radius 60 mm
and there is a lever on the shaft. Now a 200 Newton force equal opposite parallel forces, this will form a couple. And then we have another force 400 Newton. Okay, now we have to replace this couple and this force with an equivalent force acting on the lever. Equivalent force means the net effect is unchanged. So replacing this couple and this force, we are going to find the equivalent force and where to place that. That is the question. So replace the couple and force by an equivalent single force applied to the lever. What is that distance? Where I will place that on the lever? This is the question. So let us quickly recollect what we understood about this force couple system. Okay, say we have a rigid body and there is a force. Okay, let's say this is a point. Now generally the point of application of the force cannot be changed. So what is the effect of this force on this body? It will try to pull, and also about O it will also rotate. Generally the point of application cannot be changed. If at all we change, then what do we do to have the same effect of this force on the body? You can alter the force, you can change the force, or you can shift the force, but the net effect should not be changed. Okay, what do? We introduce a force of same magnitude, opposite in direction, the net effect is unchanged. Now this force and this will form a couple, so I can replace or I can shift this force to O by introducing a couple. What is that couple? The couple will be equal to the moment of this force about O, right? So force into distance between this force and this force, that is the distance. So this is the magnitude of the moment. If I am introducing a couple, then upon shifting the force, the effect is unchanged. This is the concept. Now if a couple, and also we know one more thing, couple is a free vector. When you have a couple and a force at a point, now upon releasing the force to a certain distance, right, or upon moving the force to certain distance, the couple is released. Okay, so the effect will be the same. What will happen? So this force will go to this place, the couple will be released. Then what would be the distance? The distance is nothing but moment by force. If I know this distance, I can shift this force, releasing the couple. Now when you are shifting the force, you may have a doubt whether to move it left side or right side. Okay, it is based on the direction of the force, okay, direction of the couple. Okay, if this is anti-clockwise, then the force has to be moved
So here, now about this point, it is producing an anti-clockwise couple. Okay, now there's a couple acting here. I'll just quickly draw roughly here. So this 200, 200, what is the distance between the forces? This D, that is 2R, so 120 mm. So the distance is 120 mm and the force is 200 Newton and it is clockwise couple. So this is the couple and the magnitude of that is 200 into 120. Right. Now I have to use the concept which we discussed now. If I have to move this force here, okay, what will I do? I will move this force and introduce a couple, magnitude equal to force into perpendicular distance. Okay, so what I am going to do now? I am going to do that. So let me see what is this perpendicular distance. So I know this is 300 and this is 60. So this is 300 cos 60. So it is nothing but 150 Newton, sorry, 150 mm. Now the couple is, I am now shifting this force here. Introducing a couple, another couple, already a couple is present, another couple I am introducing, that will be equal to force into perpendicular distance. So this is the force direction, the perpendicular distance is this, okay. So this couple will be 400 into 150, right. Now this force plus, if you are adding these two, okay, so 24,000 and then 60,000, so total is 84,000 Newton meter is the couple. So now if I have to draw another diagram, what is happening? Okay, couple 84,000 and force is here 400 Newton. So we know couple, we know the force. In order to avoid the couple, what we have to do? We have to move the force. It is a clockwise couple, or moment of the couple is clockwise. So I have to move in the lever. What distance I have to move? That is the question. Okay. So I'll take that. Say assume some point here. I'm going to move this so that my 400 will come here. And what is this distance? I do not know, which I have to find out now. X. Okay. The perpendicular distance is D Now how to find out D? D equal to moment. Okay, this is the moment or couple by force. So 84,000 by 400. So this distance is 210 mm. But what is asked from the question? From the shaft center, okay, where I have to move this force, or the distance between the shaft and the one single equivalent force. When I am shifting this force there, this couple will not be there. The couple will vanish. The moment I get this distance and I am shifting the force, the couple is vanishing. It is not there. So the couple and the force both together acting here will produce a particular effect. The same effect will be produced by this force at this location, at this X location. That is what we are finding now. Okay, so it's just triangle. We know this is 60. So X cos 60 is 210. So X equal to 210 by cos 60 is 0.5. So it is 420 mm. What is this distance? 420. What was initially the distance? 300. When there is 300, when the distance is 300, or when the force is at 300 on the lever, okay, this couple is present and together producing a particular effect. Now we have removed this couple, we have removed this force, shifted to some place, and this is the single equivalent force 400 Newton with an altered distance to produce the same effect of this couple and the force. So the same force is shifted, but the net effect is not changing by shifting this 300 to another 120 mm. I hope you have understood this. Is there any other way to find the same? Okay. Now see here. There is a couple. Okay. I'll quickly draw here again. We have a couple here. This couple is 24,000 Newton meter. We have a force here at 300. Okay. Now, already we discussed couple is a free vector. So if I am placing this couple here, okay, now in this point we have a force and there's a couple. In order to change this, in order to remove this couple, I have to shift this force here, okay, to a particular distance. So now D I will find from this value 60. So D is 60 mm. So this will be 120 mm. So already 300, it is moved further to 120 mm. So the answer is 420 mm. If I move the force from the shaft center on the lever to 420 mm, the effect will not change. So this is the single equivalent force which is moved to maintain the same effect. I hope you have understood this problem.